We are left with one more topic, which is hybridization. So hybridization is nothing but the process of intermixing of the orbitals with the slightly different energies so as to redistribute their energies, resulting in the formation of new set of orbitals of equivalent energies and shape. Okay, so to understand it better, here we are going to study it with an example of the formation of Sf6 molecule. Okay, first of all, the atomic number of Sf6 is 16. Electronic configuration of Sf6 will be 1s2, 2s2, 2p6, 3s2, 3p4. As the atomic number is 16, it means that it will have 16 number of electrons. So 2 to 4, 6, 10, 2, 12, plus 4, 40, plus 4, 16. Okay, 2 plus 2, 4, 4, 6, 10, 10 plus 2, 12, 12 plus 4, 16. Okay, now this is the electronic configuration of sulfur. This part means 3s and 3p. This is the outermost shell. Okay, so we will represent it in the form of orbital diagram. This is what we call an orbital diagram. In the earlier chapter, in the chapter 2, you had studied that in case of S subshell, there is one orbital. In case of P subshell, there are 3 orbitals, and in case of D subshell, there are 5 orbitals. Okay, so we have just drawn the orbitals present in it. S is having 1 orbital, P is having 3 orbitals, and D is having 1, 2, 3, 4 and 5 orbitals. Okay, so this is the orbital diagram of the outermost shell of sulfur in ground state. Okay, so in excited state means when it gets energy, then in that case the paired electrons present in S and P orbital jumps into the higher D orbitals, higher energy level D orbitals. Okay, so in that case it becomes unpaired, and each orbital will have 1 electron. So in that case 3s will have 1 electron, 3p will have 3 electrons, and 3d will have 2 electrons. Okay, so total number of 6 electrons will be distributed among these 6 orbitals. Okay, now these 6 orbital will get hybridized. There is one s orbital, 3p orbital and 2 d orbitals. Okay, so these 6 orbital will hybridize among themselves. Okay, and they will form 6 hybrid orbital of sp3d2 hybridization. Okay, so they will form 6 orbitals of sp3d2 hybridization, and these 6 orbitals of sulfur will then form bond with the fluorine atom, and the fluorine electron will take place of the empty part of the shells. Okay, like this here. Okay, so this is how the Sf6 molecule is formed, and this is the theory of the hybridization, in which there is mixing of the orbitals. And one more thing you have to remember is that the number of orbitals getting hybridized produces equal number of hybrid orbitals. Okay, it means that if it is having 6 orbitals which is getting hybridized, then in that case it will produce 6 hybrid orbitals. Okay, so the hybrid orbital and the orbitals getting hybridized are equal.